let's take a look at several models. So I'm going to close up these models that we built yesterday, as close as they are to my heart. There we go. And now I'd like to load in some of the models I gave you off of our drive, okay? And you're going to need to go on your computers to the appropriate location. Some of you, I think many of you dragged it to the desktop, in which case you want to go to the desktop. Some of you may have dragged it to your My Documents folder. Wherever they live, I'd hope you could open them up, okay? Here we go. And oh, okay, okay.
Was it on the original? Maria, could you email it to Steve and I? And could you email it? It was on the original.
Thumb drive? Yeah.
Okay. Oh, good.
Yeah, that'd be great. Here, I can bring it over to. So here's Tom Thumb.
Thank you.
Open up is going to be a model called Simplest ABM Process Hybrid with Resource Constraints. And you can kind of guess from the name what it might be. Okay. You'll notice there's also one called Simplest ABM Process Hybrid that's even a bit simpler, but it doesn't have resources captured, and so I wanted to provide the resource constraints. Okay. So this one actually has some resources involved. It's not visual. It's not. There's another one yet which captures movement around a facility, a stylized facility of sorts. And if people were interested in that, we could likely find that. But this one is a model that captures a population. Each of those associated with two state charts. One delineating their health condition. The other, they're related to their care-seeking behavior. These individuals are embedded in a population. They're denoted with these little visual depictions, and they're embedded within a population. Okay, and we'll go up and we'll see there's nothing unfamiliar here. If you go to main, in terms of the population, we have a population of 100 individuals, and if you click on main and you scroll down, you'll find that these people are put into a random network, a random layout and a distance-based network with a connection range of 75. You've seen this sort of model many times in some of its agent features. Okay. Now, what's perhaps new to you is that in main, if you go down main, you'll see you scroll up here above the population. There's actually a depiction of the care process, and because it's real estate constrained, it's resource constrained, I'm going to make my screen full screen. I double clicked on the tab to make it full screen. You could double click on it again to make it less than full screen. So here's our population, and then there's going to be a depiction of a care process model. This specific model, we only have one care process. I have another close variant of this where there's multiple clinics, and you go to the closest clinic or what have you, and so people are associated with clinics, and each clinic has some characteristics. And if people are interested in that, I could show that to you. But right now, we happen to put this workflow with this discrete event model into the main class. And you'll see some basic characteristics of it. So here we have a resource pool, and I'm going to go out of this mode right now and still try to scroll over here. This is a resource pool of a set of right now it's just a single healthcare worker in this pool. People walk in, they are awaiting the availability of a healthcare worker. For those familiar with discrete event modeling, they're seeking to seize a healthcare worker, And if they wait too long, they balk, shown through the line at the top there. So they'll balk and leave after a certain amount of time. That's this thing here. And if you scroll down, you could see where that's captured here due to a timeout, and the timeout is given here. We view each individual as having some threshold for walking out of the facility based on how long they've kept waiting, 20 minutes to 60 minutes, uniformly distributed. They'll leave the facility here. If, on the other hand, they don't balk, then they'll have seized the resource. They'll have been associated logically with the healthcare worker, and at that point, they'll be administered treatment by this healthcare worker. We could think of this person as giving them a vaccination or offering them some checkup. And there's a delay time implemented by a triangular distribution in terms of number of minutes. In this case, it's 10 minutes on average, but it could be as little as 5 and as high as 15. Okay. Now, this all looks in its basic features like a standard discrete event model, but things start to be a little bit different in this next step here. Here, there's a determination as to whether treatment was successful or not. Okay, was treatment delivered successfully or not? And you'll notice that the distinct features that are down, it's just determined by a probability. In general, it can be determined based on some characteristics of the person, the agent. And we actually send the agent a message saying that they're cured. Okay. There's another variant of this model where there's 2 outcomes for each sent with a message. The person is sent a message saying you're cured, or you encounter an adverse event. Here we're sending a person a message. Where have we seen this sort of thing before? Can anyone riddle me that? Where have we seen this sort of send some message? Yeah, it's associated with the state chart. This reflects the fact that in any logic 7, all agents are entities. Agents and entities are the same thing. So any agent can be transparently an entity in a discrete event modeling. So here, we're talking about the entity, but that's actually a full agent. That's an agent, and they have all the characteristics of the agent. They have the state chart of the agent. They can receive messages. So we're sending them a message just as if they're an agent in a network or something. And we'll see where that message is handled. Let's go to person. And you'll see that there's a receipt of a message here. And, okay, that's kind of a mixed metaphor here. Sorry, I was doing this on early morning LA time, preparing for boot camp, and there's kind of a mixed thing. So you're cured, and then they say I'm vaccinated. Okay, I should say I am cured. Okay, so I am cured. I was cured. So that message that's sent to them as they flow through brings them from this state to this state. It changes their underlying health state if treatment was successful. If treatment was conferred successfully, the agent who has presented for care is now changing their health state. If the treatment was unsuccessful, they're left with the health complaint. Okay, let's go back to this state chart, or to this discrete event model. They release the healthcare worker, no longer logically associated with the healthcare worker. There's some period of post-treatment observation, and then they leave this discrete event model. Now, leaving the discrete event model, they're no longer within the discrete event. They're no longer under care. They're no longer in the care process, but they remain in the population. And so they may represent for care later with that underlying health complaint. So you'll notice this key point here where we send them a message to cure them. That actually is the key thing that allows them to shift their healthcare status, okay? Now, this other state chart here is triggered if they go from not under care to under care under a certain condition. Can anyone in the group here describe for me the basic logic of this transition? In other words, what is it? Under what conditions will someone come in for care? How much chance does someone chance per day does someone have to present for care? 1% per day chance for elicited care. But you notice there's a guard on this. The guard, what is that guard saying? Yeah, you got to have a health complaint. So you're only going to go for care if you have a health complaint. Now, if you're dumped back into the population without your health complaint having been adequately addressed, you're likely to re-present for care because of that. You're just going to be coming back. And this issue of representation is a very important issue for a lot of healthcare facilities in terms of optimizing their processes, because they can try to increase throughput and get people through faster, but if the quality of care conferred is adversely affected, then they may be getting people through more quickly, but those people will represent. And for our LA context, this was a major issue because they were very concerned with being able to not only cure the health condition, but change attitudes. So you'd want to change attitudes which would lead to the likelihood of redeveloping a health condition. Maybe the health condition was a tooth that has a cavity in it, and it's bothering the person. They come in and present for care, but you want to change their attitude towards brushing and flossing, so they're less likely to represent with cavities again. So here, what I'm trying to say is that if the underlying health condition is not dealt with adequately, they're likely to represent for care. Okay, they're likely to represent for care and to do so until it's adequately addressed. Okay, now going from this state of undercare, so this undercare state is actually implemented while they're in the facility. Now you may wonder, why do we need this state? Well, among other things, it's to make sure that they don't go back and try to represent with the health complaint. We know they're getting care right now, so they're not going to go walk to the facility again. Okay, so they're under care for some period of time, and then as soon as they're discharged, as indicated by discharged message, they return to the not under care state. Let's go see where that's done. Here in this model, we see when they exit, they're sent a message called discharged. Do you see that? They're sent a message called discharged, and that means, okay, you can leave. You're leaving the facility now, so they know that they're no longer under care. So here, sort of the key feature, the nexus, the kind of place where these two articulate or come together, are these places where messages are being sent. Another place which we don't really take advantage of here, but in general we would, in some of our work with our Ministry of Health, might be the person's characteristics are checked. For example, when was the most recent time they were here? What's the nature of their conditions? And they'd be handled differently under different care pathways based on those characteristics. Very important because within our emergency room situation, a very large fraction of all cases, about 40% of all cases for our emergency room situation, come from either individuals who are either have multiple comorbid conditions, they have multiple conditions which bring them back again and again and again to the emergency room, or they have mental health issues and they present related to the mental health issues. 40%. And you're going to be wanting to treat those types of individuals differently based on their characteristics and based on their history. Another thing that we're interested in provincially is sort of a patient-centric care sort of model where the same set of healthcare workers across different areas, say doctors, nurses, physiotherapists, join together to serve a given patient, regardless of when that patient comes in. So in other words, if a patient represents, those people know their history. They have that context. They're familiar with what happened last time and this time. So they have that extra level of information. And that would be something undertaken at the beginning of this process and could be captured because we know the history of the individual. Let's run this model. Visually, a lot of the things I'm talking about. So here's the model. Here they all are needing care. You notice when they turn black, they're actually presenting for care. And a fair number of these people have, so some of them are here, some are awaiting resources, and time is passing. Some will end up balking out this way. You'll notice these numbers here. So 24 have reached this point, and 3 have reached this point and have gone out via here. 3 have reached this point, 3 down here, and 3 have been conferred treatment successfully, and 6 have been discharged. 6 have balked so far. Now 7 have balked. You notice these individuals who are green have been, they're turned green based on if they have a health complaint. So if they're green, it indicates their health complaint has been cured. If they're red, they have still a health complaint. Black indicates they're in the facility currently. This indicates the availability of or the use of the healthcare worker, which is the only resource here. And you see 0 to 99%. There's a certain number of requests in place right now, and you can see from whom these requests are occurring. So there's different people in the system, which you'll recognize their names, who are requesting the services of this healthcare worker. And of course, we could go and change the assumption about, say, how many healthcare workers there are, and see if it implements balking. So if we ran that model, which we just saw longer term, and we just ran it out, of the 388 people who were discharged, 278 went via this balking. Were balking. If we went and we increased the number of healthcare workers from 1 to 2, for example, and we were to rerun this, now we would see a situation where we have of 420 here, 309 were so of 420 sort of discharged, 309 were balking. So a lower fraction, it seems. In any case, so here we have this model. It integrates together the ABM model, a person's characteristics, where they are in their state chart, using features of this oval, their fill color based on whether they have a health complaint, the line, the sort of border, whether or not they're under care. And we've seen that within the care pathway, we can interact with them as agents. Here, sending the messages, in general, checking their characteristics and handling them differently. The agent can also accumulate information on how long it's been since they were under care, how long they spent waiting, all those sorts of information that you might want to accumulate if you were to decide, for example, is that agent going to come back to this facility or a different facility? All of this is captured here in Maine for simplicity, but it goes without saying that we could take all of this and we could add a clinic class, put this in the clinic, and have people present for care at, say, the nearest clinic. Do people want to see that? Huh? Yeah. You want to see it? Okay. Sure. You want to see that done? Okay. Sure. Okay. Yeah. Let's talk about that. Thank you, David. I meant to describe this. Let's look at that key nexus. This is the other key nexus here under care. Main.walkin.take. That says take me in. Take me in for care. Let's do it. Okay. So can we if you're not averse to it, because we want to go through several hybrid models, can we build atop this hybrid model rather than creating a new one? I mean, most of this is very familiar with you, but it would take a few minutes to drag the things from Palette. Okay, so let's save this. and let's call this, let's call it, what, MultiClinic, MultiClinic ABM process hybrid, ABM process hybrid, something like that. What do you think? Okay. And I'm gonna give it the designation of your fair state. Okay. Okay. So you tell me, ladies and gentlemen. This is not my hidden agenda, but now I get to ask you questions. Okay. So how am I going to add a clinic? Okay. Create a new agent type. Good. Good. It is a class as well. New agent type called clinic. Okay. We're going to describe clinichood. And let's give it a visual depiction, shall we not? Okay. Let's go down to what we used yesterday. Okay. And let's go pick that. And what do you think? A clinic, should we do a retail store maybe? What do you think? Yeah. There's a bunch of other pictures available too, but I don't, maybe Priestry can find them for us. But when you go to create a new agent, you can use all these. I noticed informally that some of the people in the audience have been making use of some of the other pictures that are available. Some have even been creating their own pictures in a artistic feat. Okay, so let's call this a clinic picture or something like that, right? Okay, so we dragged it into clinic. What else needs to live in clinic? Okay, good, that discrete event system. So right now it lives in main. So we're going to need to go grab it out from main and put it into clinic, right? Priestry, could you take note of this example? Yeah. So what we're going to grab out, let's grab out this, and then let's get these two things off to the side, this function and get count agents under care. We do want them, yeah. We don't want to take connections, okay? How did I do that? Let's do that again. This is a bit of user interface sort of stuff. So I went like this, and I grouped that, and then I held down my control button and clicked on this and clicked on that. Is that okay? You could copy them one at a time too. I mean, it's not that big a deal. Okay. I'm going to cut, and then I'm going to go to clinic, and I'm going to paste. Here we go. And in a clinic, why have them off the screen there? We just avoid hiding, drag them down to their rightful place. Okay? And then I could select them, and I can use, oh my gosh. It looks like there was some serious distortion going on. Okay. Zoom out. And then this thing and this thing. Hey, come on. Come on. Okay. And then I'll drag it down. Boom. Okay. Okay. Who needs Priestry help? Okay. Okay. She springs into action. Great. Thank you, Priestry. We just copied from main, and we just went and pasted into the clinic. Okay? Okay. Now, what do we need in main now? Now that we have all these clinics, what do we need in main? If we've taken that out, what do we need to run a model with a bunch of clinics? We need a population of clinics. So how are we going to do that? Yeah, drag. Okay, thank you. Drag it in. So we call clinics, right? This is a population of agents. And let's make, what, 5 clinics, something like that? 5 of them for 100 population, right? Puts this up there. And then we're going to have each, yes, okay. So let's now go, okay, let's Okay, so we dragged in clinics. We created 5 clinic population. Okay. Okay, let's now go to person. Why am I going to person? What do we have to change about person? Think about yesterday's institutional mobility model. We have to what? Yeah, we have to assign them to a clinic. Now, we could do this statically. You have them figure out their clinic at the beginning time. They present for care. They go to the closest clinic. Maybe we should do that because that would afford us a chance, say, to add in clinics over time and see how that affects things if we wanted to. We could add in a clinic. We could say add a clinic and place it and see how that changes things if we wanted to. So it's a little bit more flexible, okay? Notice, by the way, I fell into our vernacular, my discipline. I say we can add it dynamically, meaning we can add it while the model's running, in the course of running the model. Great. So the key thing will be this under care here. Right now we have this main.walkin.take. What do we need instead? Good. Good. So why don't we get a clinic? We're gonna pick a clinic, and once we have a name for that clinic, call it C. What are we gonna write instead of main.walkin.clinic? What would we write? No, we could just do c.walkin.clinic. Yeah. So ladies and gentlemen, there's any number of different ways we could do this. I mean, if we wanted to do it in the most terse way, we could do get nearest agent, and which agents are we going to ask about? Okay, where do the clinics live? In main.clinics, and then we could just say .walkin.take. What do you think? So here we're going to get our nearest clinic, and then we could consider it sort of walk-in area, and it says, take me in. So that's one way. I feel very ambivalent to that. It enjoys brevity to recommend it, but I'd almost rather say clinic, my clinic equals this, and then say my clinic.walkin.take. It makes it clear it's like a clinic, the specific clinic, or closest clinic, closest clinic, and say, I don't know what you prefer. I think this is a little bit clearer. It's a little bit more transparent. It makes it clear to someone I'm finding the closest clinic. Sorry? Oh, yeah. Put it up on the big screen? Okay. Sure. There we go. So get nearest agent. This is main.clinics. It's main.clinic. It basically says, take me into you. And this walk-in, can I go show you what this walk-in thing is? Walk-in was, let's go to the clinic. Walk-in is this thing. See this walk-in? See what walk-in is? It's this thing here, right? You see that? Okay. So let's go, back down to person. So we're going to ask the clinic's walk-in location to take me in. Right? See what I mean? Okay. Yeah. And basically, any logic library says inserts the given entity. And remember that key point I emphasized before. In any logic 7, in contrast to earlier, Any logic 7, agents are automatically entities in any logic. So you'll notice this says for the take, the specification of what take does, it says, you see it takes an entity to do its job. See how it says entity here? As a so-called argument, a formal parameter to it, inserts the given entity into the process flow. Okay? So basically that takes them on. Okay? Takes them onto the process flow. Yes? Entities are all agents are entities, yeah, in any logic 7. For that, you're going to have to come to the Java tutorial. So let me, can I explain that in a very brief way? Okay. I would love to show a diagram now, but it will divert us. So in Java, there's a thing called a type hierarchy. And basically it specifies a thing. So a person is an agent, okay? So, if you go and you meet a cardiologist, you go and you meet an orthopedic surgeon, you go and you meet a respirologist, I guess they're called pulmonologists here in the States, you go and you meet a nephrologist. These are all doctors, right? And in general, you could say, well, doctors in general, they have a residency program, and in general, they have some period of training in medical school, and then they go to residency, and all that's true for each of those, right? And if we said, this is a continuing medical education program, and it takes doctors, then a nephrologist could go to it, and a cardiologist could go to it, an orthopod can go to it, and whatever I said, an internist or what have you could go to it, okay? Any of those, because they're a doctor, right? They're a doctor. If we said our program, this is a medical licensing exam only for doctors, any of them could go to it, because they're all doctors, right? A person is an agent in the same sense. Anything that handles agents can handle a person. Does that help? Now, main is also an agent. And so there's a bunch of mechanisms that can operate on person or on main, and they could also operate on, if you created a deer class, operate in the deer class. You created a patient class, it could operate on that. All of those are agents, and they can be treated as agents. Now, every agent is also, there's a bunch of things above that. Ultimately, it boils down to they're an object. They can be printed out, for example. Any of these things can be printed out because they're an object in Java. And so you have this kind of specialization hierarchy where you have these more general things up there and these more specialized things further down. It just like talking about real world things, so we have an apple, a banana, an orange, they're all fruits. And so if you say, I want to eat a fruit, then you're willing to eat one of those sorts of things. Is that helpful? Okay. Yeah, and this is very important because there will be times, there will be times where you're going to see it. Watch this. Get nearest agent. Here it actually returns back something that's actually it returns back an agent. Any logic 7, it actually used to return an agent with a capital A, and you'd actually have to say, treat this like a person. Any logic 7, it's better. You don't have to worry about that as much. But occasionally you'll see it, and you'll notice this thing here has to be an agent. I can't pass it, show me the nearest string. Say, that's not an agent. Not an agent. You're passing me something that's not an agent. It's not a list of agents. You're giving me a bunch of strings. I don't know what to do with them. This has to be agents we give this thing. And clinics are agents, so we're fine. Make sense? Yeah. Clinic's an agent, main is an agent, person is an agent here. Yeah.
I don't know if this is new in any logic 7.
Yeah.
But I remember that in any logic 6,
yeah.
we have to use source, and after that call it inject, but we have to create a class.
It's different, yeah.
The whole thing now is entry and exit points.
Yeah.
The ones that you just use for
So we don't have to worry about inject anymore.
I also have, this is just a comment, maybe during the Java session you could explain more about polymer system.
Yeah, I'm going to be talking about that. I'm going to be talking about that. Yeah, exactly. And AnyLogic 7 supports a rich way to extend agents so that you could have, for example, you could define personhood, and then you could define a doctor and a patient, and they're both persons. So you have all the common characteristics of person, and then doctor and patient each have some unique characteristics themselves. Patients have a band around their wrist, and doctors have a residency institution and a white coat or something like that. Does that make sense? Yeah. So yes, you can take advantage of it. And yes, I'll probably be talking about it. So, okay. Okay, great questions. Any other questions here? Okay. So shall we run this thing? Let's just see. Okay. So here you have a variety of clinics, and if you go down to a given clinic, you should see, okay, one person has come. Oh, 2 people now. Let's go up to another clinic. Here's clinic 1. Okay, we have various people in them. 4 people have presented for care there. Okay, clinic 2, it's a different number. 6 to this one. Only 1 person has come to clinic 4. What do you think about making the clinic size depending on how many people are in it? We know how to do that, right? Let's go to the clinic. In fact, oh, look at that. Wow, we can just use that. It's a function. It returns the number of agents under care. Let's make the size of this dependent on the number of agents under care. What do you think? Okay. Should we specify the scale? What do you think? But folks, let's learn how to let's graduate from the basics. Let's define a function that says get scale, please. It'll make me feel uncomfortable as a software engineer. So get visual scale. We're going to define a function call, and we're going to call it in those 3 places. Okay? Define a function, get visual scale. Otherwise, they'll feel I've abused you in terms of teaching you. Get visual scale. And what it's going to return is whatever formula we want to use. So you want to use 0.25 plus the of agents under care times 0.5 or something like that. What do you think? Something like that? What do you think? Is that okay? So, by the way, I created this function, and then I said return double here. Okay. Okay.
And then it's creating a problem with this that you cannot.
Oh yeah, no, you don't want to do it. You want to do main.clinics, right?
But I didn't have it plural. No.
Oh.
What do you?
No, it's not. You don't want that one. You want the one. Let's go in main and see what the population is called.
Oh, I might not have done that.
There's a need to be a population of clinics.
Thank you. Sorry.
Yeah. There need to be 5 clinics, sir. Okay. So, folks, we just created a thing called get visual scale. Okay. And it's going to return 0.25 plus 0.5 times agents under care. Okay. Okay. Are people okay with that? Okay. And the other thing you have to do for this function is you got to get it to return a double. You have to say returns value double. And it's called get visual scale. Returns value double. Okay? People okay with that? Returns value double here. That's key. And this is the thing that's going to return. Just going to return a little result of a formula. And why are we doing that? Because then we don't have to repeat the formula many times. We just go up to here and you do scale, and each of them is going to call get visual scale. Get visual scale. Get visual scale. Okay? You don't. What's that? Yeah.
Would it make any difference if we just skip the scaling in Z? If we're dead?
Oh, yeah. That's a good question. I think it might make it flatter if we were to do that. So.
Would we see it though? I mean,
yeah, we could do that. So here we go. Here are these little. Oh, look at that one. That's a bit tiny, eh? Look at that. Ooh, look at that. That's one big clinic. Yeah. Okay, so that's indicating the number of people in them, right?
That one's getting more full and making more people go to that one.
Yeah. Yeah, right. I mean, we could have people go to other clinics based on how many people are at any one clinic. This one is situated more. So, folks, do you need help? Who needs help? Okay. Okay. Yeah.
If something's not connected somewhere.
Okay. So, could I see the error again? Can't leave. Wait. Out timeout. It is okay. Could I see it? I think you may have missed a thing in copying it.
Okay.
By copying this. Yeah. There was a balking thing that went up like that.
I deleted it from there too.
Maybe you deleted it. There was a thing that went up there. It was around the top of it. Yeah.
Okay.
So what you need to do is you need to draw. It's in. Well, here let's copy one of these guys. Copy paste. Yeah, good. And then you need to connect this guy to that, and then over here to that, and then you need to go like that, and then you need to go. Well, you don't need to do this. But, okay, why don't you save it? See if it's a happy camper. Okay, and then let's try this. Happy. Okay. Okay. Who else needs help? Who needs professor? What's that? Okay. Sorry?
Why can't this resolve name? Name cannot be resolved.
Okay. Are you in person? Yeah. Okay. Main cannot be resolved to a variable. Okay. Main.clinic. Yeah. Because it's no. Okay. Let's go take a look. Okay. It is called clinics with capital C. Okay. That's interesting. Really interesting. Okay. Let's try this.
Control C.
No, this dot get underbar main. Let's try it that way. Just see if it's. So this is entry action there. Yeah, I don't see a problem with that. Okay. Get main is undefined for person. Okay, that's really interesting. Oh, did you delete a main? Oh yeah, there's no main here.
Oh, I bet we pulled it over when we pulled in that.
Yeah, it was probably pulled over to the clinic. So there's some mains that this here or something.
Right there. It got pulled over. Oh God. Because everything was mushed together. Yeah. Everything was so much. I changed the font size on this computer.
Oh yeah.
Which made everything like.
Yeah.
So that was why it was a lot harder.
Okay.
So we just need to cut out that main, right? Cut and paste that main.
Yeah, it was a drag and drop.
Yeah.
Oh.
I was scared of
I probably should.
leaving a piece behind.
Yeah. I did that.
Yeah.
We just Control X and Control V that.
Yeah, but we need to put it in person. Person here.
Yeah, it
doesn't. No.
It doesn't contain that main, so it cannot resolve it.
So.
Yeah.
No, you can't copy it.
It can't.
No. I think what you should do is you should probably create a new person and paste it in there.
I'll do that.
Yeah, you just create a new. Need that. This would be per.
Person one.
Oh no! I'll get rid of this. Okay. Delete. Boom. Boom. Go away. Okay. 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 New.
What happened now?
New agent type. Okay. Okay. Person. Okay. Here we go. Okay. and then you do this, but then there was also this connections one. We don't want that. Boom, go away. Okay, method get main. Okay, still not defined. Okay, okay, you're gonna have to work with it. Yeah. Okay. So anyone else have any questions on this? Yes.
Is there a way to have it record the time when all of the stuff turned green?
Yeah. 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 Okay. Let's do that. Okay. Let's do that. Yeah. Yeah. Right. Okay. Let's try that. Okay. So the question was from a student: is there a way to get it to record when all the agents are burning? Okay. I'm going to just try one strategy. There's several strategies I could think of, but this is one of them. Okay. Event population healthy. Okay. Okay, and let's just see if we can. So it's a condition, and the condition will be based. Oh, sorry. This needs to live in Maine. Okay. Okay. This needs to live in Maine, and it's based on. Let's have the population count the number of people who are unhealthy. This is probably the easiest way to do it. So in Maine, have it count the number of people who are unhealthy, and we'll see if it's 0, right? Add a statistic in Maine. Count unhealthy. Count unhealthy people. Something like that. It'll be a count. And what are we going to base it on? Anyone? Who wants to? Yeah. That's right. So it's called what? Health condition state chart or something that they're in. Okay. State chart health condition. Okay. Okay. So let's try that. Oops. Sorry. So we want to do population statistic, and this is going to be item.state chart health condition dot is state active, and it's going to be person dot without person with healthy, right? The formula for the statistic we're adding. We're adding that statistic to the population to count the number of unhealthy people, right? And what's the event going to be triggered by? If what? Then how do we tell if the entire population is healthy? If the number of unhealthy people is 0. So we could do. Tell me what I'd type here. Do you know? Who do we have to ask for the statistic? Where does the statistic live? It lives in. It does live in Maine, but within what? Population. So we'd have to ask. You could say this population dot count unhealthy people, and then how would we test if it's equal to 0? Equal to 0. So what did we just do? We added to the population something to count the number of people who have a health complaint. We call it count unhealthy people, and then we made this event be triggered when that's equal to 0. We're going to say trace ln, the population is fully healthy at time and the current time. Something like that. Does that make sense?
Yeah, but there's no built-in way to have, because the model will read
Right. 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 You, not to my awareness. I know what you mean. It would be nice if you could get it to stop, for example, at some condition, but I'm not aware that that's possible right now. So what you can do is you could have this go up, and then I think you could tell the model stop. I think you could actually tell the model, like, and I don't know, I don't remember how to say it. Engine. Could probably tell it like stop. Here, stop. Oh no, stops movement. Stop simulation. See that? Okay. See this? Stop simulation. You could probably call stop simulation when this goes off. Okay. And this is in this event population healthy. So before we did this, pre-ESRI will note, we added an event called event population healthy with a condition. Under this condition, the current time will stop the simulation. And this condition uses a statistic, pre-ESRI. This condition uses a statistic called count unhealthy people, which is defined in the population to count up the number of people who have a health complaint. Sure. Okay. Yeah, it's great. It's great. It is great. Yeah. Okay. So can we try this? Let's just see if it works. I think this will work, but we have an alternative way if it doesn't. Oh, do you need me to go back to that? Okay. Let me just. Okay. I just ran this, and you want me to go look at this guy or this population statistic? The statistic is this. Count the number of that person. Their state chart is indicating that they have a health complaint. Okay? Okay. And let's just see if this printed out something, though. Your name again? Siri? Okay, Siri. Thank you. And it looks like it was a nice idea, but it didn't work. That's interesting. Okay, let's try this instead, okay? We'll do this with a timeout every one time unit. We'll check, and we'll check that condition, okay? So I'm going to take that same condition, and I'm just going to check it every time unit and see if it's true. There should be a better way to do it, and I'll see if I can figure it out. But here, cyclic with a time of one and work. I've got to think about that more. If this thing equals 0, then we'll print this thing out. So here we're just checking periodically with every time unit. Does that make sense? Yeah. But there's a more sophisticated way we could do it. With each person, when they recover, we could say, hey, are you the last person to recover? If so, record the time or record the last time they recovered, that sort of thing. That would work perfectly well. So there's several ways we can do it. This is kind of the poor man's solution. And I feel embarrassed showing this to you, but it'll work. It'll work. It's roughly, okay, there we go. Population is fully healthy at time 667. Oh, look at that, though. Look at that. Population is fully healthy at time 665. 656. Okay, so at least it seems that people are becoming fully healthy several times, which is interesting. Okay, I've got to double check that statistic. Did I inform you of the wrong statistic? No, it's with health complaint.
Mine just kept running. It might be that the model isn't stopping because you supposed to do event checking.
Uh, I don't know about that. I mean, this thing is, so it can only go one way. So once you're without the health complaint, if nobody's with a health complaint, you would think it would mean that the model is, no one can develop it further. It's just that this is printing it out several times, 756. Maybe it's taking a while to finish or something. Yeah, maybe that it's taking a while to finish, but it's free of unhealthy people by 755 here. But you'd really like it to stop sooner. So I'm gonna have to come back to that though, because we want to get on to these other things. There's a more clever way to do it based on, with each individual, record the time the last individual recovered, and then you look at the last of those at the end of the simulation. You look at the most recent of them. Okay. Anyway, this is one hybrid model of several we want to look at. So I'd like to move on to another one. So this is